So the high-rise buildings is generally defined as one the taller than the maximum height which people are willing to walk up. This is requires um, the height which people or mechanical and vertical transportation. So this includes a rather mm, limited ranges, um, limited of primarily residential apartments, hotels, office buildings. So a type mm, that appeared recently is mixed-use building, which contains varying amounts of largest buildings. The units of cost are relatively high, so the commercial or offices functions require a higher degree of flexibility. So what is the high-rise structure? So the main meaning of the high-rise structure building. So high-rise building became possible with the invention of the elevators, lift, and the less expensive, more abundant building materials. So the material used for the structural system of high-rise building mostly are reinforced concrete and steel. So the most skyscrapers have the steel frame, while residential blocks are usually constructed of the concrete. So actually, there is no clean difference between tower block and a skyscraper. Also, a building with a 40 or more stories and taller than 150 meters is generally considered like a skyscraper. So high-rise structure pose particular design challenges for structure and geotechnical engineers, particularly if situated in the seismical active region or if the underlying soils have the geotechnical risks factors such as higher compressibility or um, mud layers in the soil. So they are also posed serious challenges to firefighters during emergencies in high-rise structures. Um, New and old building design, building system like uh, building standpipe system, HVAC systems, so heating, ventilation, air conditioning, fire sprinkler system, other systems, elevator evacuation posts, so significant creates a significant problems. So studies often um, ensure that pedestrian wind comfort, wind dangerous concerns are addressed. So in order to allow less exposure to transmit more daylight uh, to the ground and to appear more slender, many high-rise have a design with setbacks. So the large scale urban centers have entered the 21st century with the paradox of discussing so about the demand of the um, skyscrapers. So as the cities touch the ski with their growing skyscrapers, they also um, reach out to attract and embrace um, as many people as it possible. So aiming to become an important financial, commercial, cultural, technological, or touristic place, therefore attract investment. So they need to grow actually. So the more cities grow, more people are needed to make it grow. So with more people, more infrastructure are actually necessary in the big cities in with the big population. So on this going trend, tall buildings, skyscrapers appear both as prognostic or antagonistic. So, what about special points of demand? So, it is scarcity of land in urban areas. So, we know when the population is a grow, it needs a place for living, for working, and so on. So, there are a deficit, scarcity of the land where can be constructed low-story buildings or many-story buildings. So it suggests one solution to construct the high-rise buildings, which will give more opportunities for living and for working. So increasing demands for residential business places. Again, so increasing the population, the increase the number, so the government should increase the number of working places and the residential places. Economical growth. So when the city, when the country have the good and the power economical conditions, actually they can construct the high-rise buildings because it's require many expense. So technological advancement, innovation of structural system. So system should be applied, the good system should be applied for high-rise buildings and actually should be strong enough to protect the buildings during the life cycle and to have opportunity accept all loads and transmit it to the soil and foundation. So desire for aesthetic in urban settings, concept of city skyline. It is important for architects. They should apply the right place, the right design for sky for these buildings to make uh, con- the good concept with the city life, with the uh, existing buildings and so on. Cultural significance and the prestige, human aspiration to build higher. So if we'll look back at the history, we'll find that in ancient time, starting from the ancient time, people tried to build the highest buildings, huge constructions, and so on. So there are no limits for the human inspiration. So there are no limits for the imagination of big constructions and so on. So that's very important. So if we will look to the main materials applied for the construction of high-rise buildings, we'll find that there are not so many types of materials applied for construction, but some of them are more popular than others. So the vast majority of residential high-rise buildings are built actually from the reinforced concrete. So some very early buildings used bricks and the concrete combination, and most modern buildings have higher proportion of steel work, but the concrete remains the standard material. And other elements may include brick block work, metal work, glass, plastic, internal cladding, aluminium, polyvinyl fluoride, cladding skin, fiber, and so on. So, concrete and the steel have long been the primary materials for the um, constructing skyscrapers. But recent years, engineers and architects have started experimenting with the new and often surprising materials in response to sustainability of the cities. So actually, there are modern materials which are also very durable in comparison with the steel and the concrete. Concrete or reinforced concrete. So, is an incredibly strong man-made mixture of aggregates, sand and gravel, cement and water that have been used in construction since Roman times. So uh, many time ago it was used. Yes, it's a very hot and in the normal state, it can withstand with higher compression loads, but in but it has a major weakness. It cannot resist tension loads, and having perhaps a tenth of its compressive strength when it's approved. So it's a good pures, but not poor for beans. For last century, the steel reinforcing wire or rebars has been embedded within the concrete slab to overcome these weaknesses. So the steel can be placed under tension either before powering pretension reinforced concrete um, or after curing post-tension reinforced concrete. So non-tensioned steel reinforced mesh can be also added um, to add the strength, the large surface areas, slab, so for typically floors. So a relatively modern addition to concrete has been fiber reinforcement. So it can be as replacement to in addition to conventional steel reinforcement. So according to the architectural and design solutions. Glass. What about glass? Glass is a hard but brittle substance, usually transparent, made by fusing silicates under higher temperatures with soda, lime, etc. So it's a brittle and does not stand a higher impact, but its tensile strength can be 5 times that of the best steel. So this higher strength and the development of the modern glass construction techniques means that a new high-rise buildings use the large quantities of glass as walling usually supports by steel frames actually. So these techniques is seldom used in residential accommodations, but all windows will be glass held by the variety of framing materials. So its melting point is normally about 1,400 degrees to 1,600 degrees. So in some glasses is a low. So, but mm, exposure to higher temperatures, it will cause to soften and lose strength rapidly. So it means that sudden exposure to any extreme temperature change, such as fire or application of cold water jet to hot glass, will cause cracking or complete failure in the structure. So failing glass, either from cracking or broken panels, are actual molten glass. Uh, is a particular hazard to all personnel below the incident. So pieces of glass can plane as they fall and they travel considerable distance away from the building. Next one is the steel. So steel is extensively used for all forms of construction and is present in nearly every form of reinforced concrete. So steel is a metal, although was major component is iron. So carbon is added, and this act is a hardener. So different mixtures of the steel are used. So we see that the lows of the strength at the 600 degrees, so the beam can lose two of its third strength. So what will happen if it will strength? So strength, the right can be found the ductility of the strings, and ductility can lead to the buckling. So and the buckling um, can be local, so maybe it will be not so dangerous, but when the buckling became the general, of course it can lead to the big problems. It can lead to the failure of all buildings. So because of the limitations in the fire, um, so the steel used in structural context. So steel is usually given additional fire protection in form of sacrificial cladding, concreting, or some barriers, so to protect from the open fire. So the steel walk barrier within the reinforced concrete, it's a large degree protected from fire by the concrete covering, but prolonged exposure to higher temperature can affect to the integrity or tensioning within concrete, leading to the failure. So fire crews the key safety point at high-rise buildings that um, structures still pose a serious failure risks, while the failure of the individual beam may not cause the collapse. It's indicative that building structure is being compromised. Next one is aluminium. So aluminium actually it's a relatively soft material, lightweight material. It have the melting point about 660 degrees. So aluminium used for with the purposes not like bearing purposes, but for additional purposes. So, for example, in combination with glass. So it can be bearing material for finishing of the tall buildings, like glassing. So we know that glassing of the tall buildings cannot exist without the supporting materials, and it can be done by the aluminium. So aluminium is can be framing material for the these purposes. So according to it, um, the melting point, it also should be protected by the special cladding materials, by the concreting, by the uh, other barriers to protect from the failing hazards and fire problems in the buildings. So it can be used in the various places, like for windows, for lobbies, for partitions. So, for example, translucent partitions, and so on. So, polyvinyl chloride, so PVC. So, this material is nowadays really became the popular material according to its lightweight. That's why it's used for construction like the framing or cladding material. So, and not only, it also can be used for sewage purposes, like for plumbing, like pipe material, for um, waste, for putting out the rain waters, and so on. We know we see that the melting points around um, 220 degrees, and it's creates some risks for the it using in open places, so that it also should be surrounded by not fireable materials. So, but PVC does not burn if it will have class 1, and the fire rating will, so when its surface will consist of the non-fireable cladding materials, and it will be protected. So it can be used for framing material, for windows, and lead to floor or floor compromises. So now we've finished talking about the materials used for construction of high-rise buildings. And now we're going to talk about loads acting on the high-rise buildings. So the loads can be divided into some, according to its action positions on vertical loads, on horizontal loads, and unexpected loads. So what about vertical loads? So dead loads arise from the height of the individual construction elements and the finishing loads. So also to vertical loads, we can say about live load. So live loads are depend on the um, number of stories. Live loads can be reduced for load transfer on the dimensioning of the vertical and the bearing elements. So, however, the reduction of the total live load on the construction element may not exceed 40%. So what about the horizontal loads? So calculation of lateral loads should be carefully constructed. So in general, arises of unexpected deflections, wind, and earthquake loads. Unexpected deflection. So it arises from it rises from the calculated load in the manufacture of the construction elements and large components. So another cause to uneven settlings of the foundation at its homogeneous side. So any deflection produce additional lateral forces, like wind. So wind loads. So wind loads in high-rise buildings are susceptible to accretion. So it should be not viewed as statically calculated load, but must be investigated under the aspect of way of behavior. So wind tunnel experiments are used to see the influence of the building, a shape on the wind load. So the ability of wind loads to bring a building to sway must also be kept in the mind. So this acceleration leads both to perceptible lateral acceleration for occupants and to maximum lateral deflections. In according with the wind loads, also one of the horizontal loads is the earthquake. So the seismology seismology is the word which means the earthquake and the word. So it's two definitions. Scientific study of the earthquakes is a requirement thing for find the uh, seismical activity nearby to the construction of the building. So it's a study of the earthquake effects, seismic sources to find the way of the wave. It's volcanic, tectonic, oceanic, atmospheric, and other ones. So the earthquake produce a different types of seismic waves. We know it, and according to the way seismic wave, we are trying to find the best constructional system, which will protect the building from the failures. So we know that the wave travel through the rocks, provide an effective way to image both sources and structure deep within the earth. So the main waves is the P waves, C waves, and the both of them. So the pressure waves, primary waves, P waves, so they travel at the greatest velocity within a solid, and therefore the first waves to appear the seismic. So, for example, the shear waves Secondary waves transfer the waves travel more slowly than P waves and thus appear the later than the P waves in the seismogram. So particularly motion is perpendicular to the direction of the wave. So shear waves does not exist if fluids such as air of the water.